Hi everyone. Hi. Sorry if there was any confusion about this session. That was bad organization from our side, so we do apologize. Um, we do have Steve here, which is brilliant, and you've got myself, Alzaris here. Henry, my co-chair, was unable to make it. So I'm just gonna keep letting people in. 1 second. Okay. Enable waiting room so people can just flow in. Okay, just give everyone just another 1 minute and then we get started, Steve. How does that sound?
Absolutely. Sounds great.
Perfect. So everyone, if you're just joining, it's been a very lovely 3 days and we're coming to the end now. So we have this lovely session by Steve Warren to kind of see us off for the end of the conference, virtual conference. So this is brilliant. This is brilliant. Lovely way to end the conference. So I hope you guys had an amazing day and I hope you guys enjoyed this next presentation. Just to let you know and to remind you, please do your session feedback at the end of the session. And if you have any questions, I think Steve said that it would be great if you guys could interact during the presentation. So leave your questions in the chat and we will just run through them. So by all means, Steve, if you would like to take the stage, it's all yours.
Absolutely. Hi, everyone. Good morning, good afternoon, and good evening, depending on where you're joining us from today. Um, I hope you're at the right place, exploring future directions with AI and IBM Z. Let me tell you just quickly about myself. My name is Steve Warren. I work in the Washington Systems Center, but I am located in Poughkeepsie, New York, home of the mainframe across the pond from the UK. And I'm looking forward to just sharing with you some of the roadmap and the journey that we've already taken with AI and Z, and then to tell you about where it's going, especially with the given announcement of new hardware that was introduced on April the 8th of this year, just a few weeks ago, when we introduced the new IBM Z or Z17. And so we're going to have a good time talking about uh, where AI is on the platform, how you can leverage it, some new capabilities that are available on the Z17. Okay, so with that, let's go on. So let's just recap a little bit about the strengths of using AI on the IBM Z platform, right? The idea is that we can enable and infuse real-time insights inside of our application. What does that mean? It means I can take an application that currently just does if-then-else rules-based types of processing and enhance it with a predictive or other capabilities with AI to gain additional insights. This has a wide variety of use cases. We'll talk briefly about them. But besides just real-time insights, we have the ability of having security, not having many copies of that data lying around when I'm moving that data to another platform for AI inferencing. Very fast, low latency scoring, high throughput, and best of all is if you've already bought an IBM Z16 or Z17, you can leverage that technology at no additional charge, as well as just the availability and resiliency and scalability attributes that are on the IBM Z platform. So just just very quickly, just saying that we've surveyed, and 84% of IT executives believe that incorporating AI into the mainframe and for a transactional scope is very important. And so what we're seeing is a great migration of a lot of AI workloads to IBM Z, as well as people who don't have any AI to be able to create some simple models or even a little more complex models and run them on IBM Z, co-located with your traditional business logic and your system of record data. So we've talked to a lot of clients, and we've we've seen the industry trends. And one of the things is that there are a lot, models are getting more complex. And so we need to be able to pivot to that as we anticipate that we're going to have a lot more input parameters into our models to generate different types of insights. We expect over the next number of years that energy consumption is going to go up significantly for some of the AI workloads. How can we address that and not incur those big energy increases? We have conflicting goals. We have sustainability goals on one side, and on the other side, we have the need to do some AI analysis. And so we're seeing that trend. Another trend we're seeing is that a lot of security breaches involve shadow data. What that means is a copy of the system of record. It doesn't necessarily mean it is that the breach is occurring at the system of record always. It could also be that a copy of that system of record is there. So what that means is having a lot more copies of data with potentially sensitive data could be a security risk for you. And so how can we address all of these things? Okay. So let's take a step back and look at the AI landscape for just a moment. We have a couple different concepts we need to talk about. One of them is called predictive AI. So predictive AI is using traditional machine learning and deep learning models for detecting patterns in the data, right? So this is typically works very well with structured data, data that's in a database, data that's in well-defined columns, for example. And we're able to gain a lot of different insights in many different use cases. Then there's these things called large language models, which have really been coming more prominent year by year. This is being able to do things like natural language processing and to do all the types of things that are associated with being able to take unstructured data and to be able to make sense of it, right? So a lot of the data we have on IBM Z is, in fact, structured data, which would fit more into the blue circle that we have on the screen. But there are a number of use cases that clients have said, you know what, but I also have unstructured data. I want to be able to process that as well. So we have both predictive AI as well as generative AI or large language model processing. And sometimes we can use both of them when we're actually looking to make an AI decision or to gain enhanced insights from AI. So let's just talk a little bit about the ecosystem stack. We're not really going to be talking as much about particular products here as we are talking about directions. But we just want to say that because IBM is very involved with every aspect of the stack, we're able to have a very tightly integrated solution. Much like how, for example, Apple is able to have the hardware manufacturer of the phone, the Mac OS, and many of the apps that are on top, they are vetted. So, right, you have a full stack view. IBM is very similar, right? So we introduced in the IBM Z16 the Telum, and we'll talk about the Telum 2. We also have this new thing called a Spire Accelerator, which is going to be available by the end of the year. We'll talk a little bit about that. Then there's the ecosystem of the AI frameworks and AI interchange formats. If you are a ZOS system programmer type of persona, that stuff looks like about a bunch of alphabet soup, right? It doesn't really make a lot of sense. But for those who are in the data science role or are familiar with many of the data science AI frameworks, the ability to be able to run those frameworks on the hardware that you're talking about is very important. And so the hardware coupled with the popular AI frameworks is going to provide a basis for what we can actually run. And then, of course, we have these two pillars, business insights, and be able to infuse AI into real time in every transaction. That's where we're going to be focusing most of our talk today about how I can take AI and add it to my existing applications to save my company a lot of money and to create real value. We also have intelligent infrastructure, sometimes referred to as AI ops. This is how we can leverage AI to help us manage our own Z box, for example, or to manage ZOS, for example, or to make it easier for folks to be able to understand, for example, ZOS concepts and terminology. We'll talk about some of the assistants and more. So we have these two pillars. We have the hardware and software. So with that, let's talk a little bit about just a history lesson quickly about the IBM Z16 and what we did on that platform. So we have this IBM Z16. We introduced this on-chip accelerator called the Integrated Accelerator for AI. This allows us to basically have inferencing at scale with very, very low SLAs. So what do we mean by that? That means, for example, for a credit card fraud detection model, with the IBM Z16, I could process up to 3.5 million inference requests per second, with the average response time being 1 millisecond. So this is tremendous scalability for AI and to meet SLAs. It's not only that we can run lots of transactions at once, we can also run a lot of transactions at once and have them complete very quickly, right? So we have lots of use case examples. We'll talk about a couple of those, what was introduced in the IBM Z16, and then we'll focus again on the IBM Z17. So what's nice about this, again, we have tremendous throughput advantages compared to putting that AI inferencing off platform on an x86 or using an NVIDIA GPU. And in additional, we have tremendous sustainability improvements. Now, this is not a typo error. It's not 41%. It's 41 times reduction of energy consumption compared to running an NVIDIA GPU for these real-time insights. So this is talking about machine learning, deep learning models that we can run co-located with our system of record, with our business applications running on ZOS. So again, this is a picture of the integrated accelerator. The reason how we're able to run so quickly is partially because of the accelerator, but also because of this very sophisticated design, which basically the AI accelerator can use the core's cache and to be able to minimize data movement for when we actually are doing these inferencing. So incredible capabilities that any of these 8 cores could leverage this integrated accelerator for AI. So just amazing what was available on the IBM Z16. And again, like we said before, the idea of what IBM has delivered and what we are telling our clients are, you can build and train your models on any platform you wish. It could be Z or Linux 1. It could also be x86. It could be on the public cloud. It could be using whatever framework you want. But what we're going to do is we're going to provide you to have the ability to have an interchange to take your models, convert them into a common open source interchange format or formats in the case of PMML or Onyx, and to then be able to then consume that and to be able to generate IBM Z instructions that can potentially leverage the integrated accelerator for AI all seamlessly. So once you've created this model and converted it into a common interchange format, we can then consume that on IBM Z and actually invoke the integrated accelerator without the developer who's building and training this model even knowing anything about IBM Z at all, right? So that's the idea behind this. So a lot of the popular frameworks on the top box, on the top left-hand corner here, we have the machine learning, and then we have the deep learning. And this is what we delivered in IBM Z16. And so you can see very, very fast performance here, right? We're able to get, for example, in this case, with a XGBoost model, which is a gradient boosting type of model, we're able to get 525,000 inferences per second with an average of 1 millisecond response time with using just a single integrated accelerator for AI, right? Very powerful. And then this one with a very complicated deep learning model, we're able to see we can scale these workloads to very high levels and very fast response times. And remember, when you purchase the IBM Z16, you already have this integrated accelerator. There is no, you don't have to pay to enable that integrated accelerator, right? So this is some of the things we're talking about. Now let's take a step and look at some of the use cases that we're using the IBM Z16 very quickly. So no matter what industry that your company is in, there is a use case for you. And we have hundreds of use cases that we have been talking with our clients, and many of them have already gone into production. Many more are in the process of going into production in the middle of a proof of concept. The key point to take here is that no matter what industry, there are use cases that where AI on Z makes a whole lot of sense to be able to leverage to gain additional insights. So let's just talk about a couple of them. We're going to talk about one that anyone can identify with, and that is the idea of doing fraud detection on a credit card swipe to detect fraud of a consumer making a fraudulent purchase. So we have a large US bank that really wanted to improve their fraud detection capabilities on-prem and score 100% of their transactions, right? But they have very strict service level agreements, right? And so they tried to implement a simple machine learning model and deploy it onto an x86 server located within their same data center. And they said, okay, so a request is going to come into Z. We're gonna take that request and we're gonna fire it off to x86, get the response back, and then that can augment our existing rules-based fraud detection that we're doing. We want to do this for every transaction, right? So the issue was that, well, it doesn't just work so neatly as they originally thought. When they tried to do this, they found out that they were only able to score approximately 10 to 20% of those transactions within the SLA window. And for a credit card company or a bank that is a issuer of a credit card, the service level agreement is king. And basically, if I'm going to miss my service level agreement, I am going to let the transaction go. Meanwhile, I can still process that transaction asynchronously and determine if it's fraud using my machine learning model, but I'm going to let that transaction go because the first transaction go because I can't afford to miss the SLA. Well, what happens if that transaction was fraud? They let a transaction go out in the clear when their model clearly stated that it was fraud. The problem is the model didn't say it quick enough, and so they weren't able to get the insights. So what ended up happening, the IBM Z16 is what happened. And they said, IBM, can you take this model and just run it on IBM Z? And we said, yes, you can do it unmodified whatsoever. You can deploy it onto IBM Z. They took that same model, they deployed it onto Z, and immediately, instead of scoring 10 to 20%, they were able to score 100% of the transactions with plenty of headroom to grow to still score 100%. What did they save? Now, this is a large bank, but it is not one of the top-sized banks in the US. Just on their credit card fraud alone, they estimated they saved more than $20 million per year. They're so excited about it that they applied it to their debit cards and several other use cases because they just said, wow, this is amazing that we can save this amount. And again, they're able to score not only 100% of the transactions, but they were able to score, instead of 1,800 transactions per second, to 20,000 transactions per second with no trouble at all. So this is just a great use case. Again, we provide technologies that allow you to integrate very tightly with COBOL applications, et cetera, et cetera. And so to be able to have this very, very tight integration of being able to call out to your scoring service of where your model is running. And in the case of Kix COBOL, and for example, using technologies like machine learning for ZOS, you're able to actually score that in the same Kix region. The model is actually deployed within the Kix region, leveraging the Telum integrated accelerator for AI. Really powerful stuff. Another use case we'll just really briefly talk about is clearing and settling. So on the other end, dealing with vendor fraud of credit cards, for example, we have a very, very large credit card processor that basically says, okay, every 2 hours I run this batch job that basically its goal in life is to pay out all the vendors that used my card and to remunerate them for the charges. So there's fraud in that side as well. And this company basically wanted to be able to detect these high risk transactions before they are actually settled. So how do they do that? So in this case, they implemented deploying a model onto IBM Z. They said, I can't elongate this batch window by having my AI inferencing going off platform. The latency and the need to copy the data, let alone the fact that every single transaction I have to pay MLC to send the data over to that other platform because I'm using ZOS TCP/IP. So they said, can I deploy this model on Z? I want to use a very sophisticated deep learning model using TensorFlow. Can I deploy that on the IBM Z? My data scientists are all familiar with TensorFlow. So in this case, they actually took a TensorFlow model that was built off of the platform and deployed it into ZCX, which is ZOS container extensions, and it's the OpenShift variety. So OpenShift running on ZOS or ZOS. The only issue with this particular use case is that some of the data that they had was on ZOS, but some of the data was off in a data lake. So they said, I want to be able to do this scoring in real time. I can't afford to go off and gather all this data. So what they did is they ended up taking their data, the last 90 days of credit card data, and populating an in-memory cache on ZOS the last 90 days. So they took the data that was off on the data lake, and as each day, the next day occurs, they take the next day worth of data and populate this Hazelcast cache. By doing so, they're able to have both a historical view of the data as well as the current set of transactions that were on ZOS DB2, and they're able to combine all of these things together and to be able to get a very amazing inference, which was under 5 milliseconds at the time they created it, at the time of this slide. I believe now they're down to about 3 milliseconds for a deep learning model inference, including preparing the data for the model, et cetera. So just really an amazing story here of leveraging ZOS and the IBM Z16. And there's many other use cases. I want to talk about the next technologies in the remaining 20 minutes that we have. So we can go on and on about lots of use cases. It's not just about credit cards or about fraud detection for banks. It could be fraud, has many flavors. It could be insurance underwriting. It could be anti-money laundering. It could be sentiment analysis and more. We'll talk much more about some of those other things in just a few moments. So this AML use case, again, was a really powerful one that we were able to leverage machine learning for ZOS and IMS. Just some powerful capabilities here that were available for very tight inferencing, very tight windows to have inferencing with about a 1 millisecond response time, leveraging that integrated accelerator for AI, and much, much more, right? And I'll just skip over that because I want to focus in on advanced AI use cases with IBM Z17. So we've had lots of clients embrace the IBM Z16. A lot more are starting to start their journey for AI on Z. But some of our leading edge customers said, you know what? what you've provided is really awesome, but I need to be able to do different types of AI inferencing on Z. I don't want to send the data off somewhere else. I have to have this done in a tight window. And I also, for security purposes, don't want to send the data over there. And I also don't want to use, I have very tight sustainability goals for my organization. I can't afford to have all these GPUs running and taking up a huge amount of energy consumption. So what can I do? What can you do, IBM, that will help me with these additional types of models that I want to be able to run? So here's what we are providing with the IBM Z17. You're going to be able to do inferencing, and we're gonna allow you to do both, continue to do predictive AI even faster than before. We're going to allow you to do some small large language models within the scope of a transaction, so you can do what we refer to as multi-model inferencing, which means I might have for a very advanced AI scoring, use several different models together to get an even stronger um, score or stronger insights into what's going on. Not just a single inference, I can do multiple ones, and we'll talk about that more. Also, the Z17 is providing a foundation for assistance to be able to run some of the assistance codes. We'll talk about that in just a moment to help you complete tasks and be able to deploy them natively on IBM Z and IBM Linux One. So we'll talk about that a little bit. And then a very hot topic is the concept of agentic AI, right? And agentic AI, when we're talking about agentic AI, we're really referring to uh, autonomous operations and the ability for the system, rather than being directed to do an AI inference, for the system to be able to detect that it needs to do AI, and for these agents to perform tasks simultaneously and independent of their human users. So this is really an amazing set of technology, and the IBM Z17 is going to allow you to do all of these things. So let's dive in a little bit deeper. So first of all, the IBM Z17, again, announced just a few weeks ago, has built on, of course, the foundations of the IBM Z. And here are some of the benefits of the IBM Z17. So the IBM Z16, you thought that was good. It could do 300 billion operations per day with an average of 1 millisecond response time. That was on my Z16 chart. How about increasing that another 50% and be able to run those same workloads 450 billion per second, per day, 450 billion inference operations per day on a single box, right? You're going to see that we've also improved the AI throughput, that we're going to be allowing you to use more than one integrated accelerator for AI if one is busy. We'll talk about that in just a few moments. And again, compared to x86 workloads, we can use 83% less power. So this is just some of the highlights of the IBM Z17 and as it relates to AI. But we're going to dive in and talk a little bit more about what types of new models can run on the IBM Z17 natively, right? So we're going to allow businesses to leverage encoder LLMs. Now, you might not know what that is, but that is an LLM type of LLM that will allow you to gain insights from unstructured data. And we're going to allow simple to medium-sized encoder LLMs to run leveraging that Telum processor, which means they can run within the scope of a transaction very quickly. So again, you're going to be able to, and in some cases, you're going to be able to have these multiple models where I can look at both structured and unstructured data all within the scope of a transaction. These are what we call multi-model use cases, and they can be still done with real-time decisioning at very, very high scalability. Okay, And then we're also going to have some generative AI capabilities that are available on the IBM Z17 that are going to leverage another piece of technology, and we'll talk about that in just a moment. So here are the technology that is making this all happen. We start with the Telum 2 processor, which is the next turn of the crank of the IBM Z processor. Again, it has incredible statistics that are associated with it, but how is it going to apply to AI? We'll talk about in the next slides. Then we have this PCIe attached adapter called the Spire accelerator. This will be available likely in the fourth quarter of this year. And this Spire accelerator is going to allow you to do some of the more complicated inferencing that's required using more complicated large language models, using generative AI capabilities natively on IBM Z. And then, of course, Gen AI software. So whether that's being able to run some of the Watson X products on there, OpenShift AI, and much, much more. We have a fully optimized integrated stack that's going to make all this technology real. So talking about the hardware itself, so again, the second generation of the AI accelerator supports a couple of things. It supports, in addition to all the things it supported in the Telum 1, the Telum 2 supports additional mathematical operations that large language models, and when we're talking about large language models, we're talking about small to medium-sized large language models that have a well, I have a chart that describes what some models can actually run on the Telum 2 processor. They can now run on that processor. We also have quantization. You might not know what that means. In layman's terms, quantization means taking a model that has big numeric data and be able to compressing that data into smaller data. Why do I do that? To be able to run those inferences much quicker without losing much in the way of accuracy, right? And again, we improve the AI processing over the IBM Z16. Now let's talk about this in-drawer intelligent routing. So what we've found out is that a lot of AI accelerators are on within a drawer are not being leveraged all the time. And so what we do is say, hey, what happens if that integrated accelerator, as people increase their AI workloads, what happens if that AI accelerator becomes busy? I want to be able to offload some of that integrated accelerator processing to another core and to another chip within the same drawer. And so with this capability, we're able to do that. And so you're able to have this remote AI processing to leverage the 8 integrated accelerator processors within a drawer for your AI inferencing. Of course, something running on the existing chipset has priority, but if that accelerator on another chip is not being leveraged with the Z17, you're able to do that. And then, of course, we have the Spire accelerator cards, which we can have up to 48 cards of them per system. We generally recommend you get them in groups of 8 cards. And this just provides a lot more compute power to be able to run some of these more complicated models and to run, for example, some generative AI types of use cases. Okay. So let's talk a little bit more about when each set of technologies are being used. If I'm doing predictive AI, so if I'm using predictive AI, for example, to do machine learning or deep learning model, a Telum or Telum 2 processor is going to work just fine. So the Telum, IBM Z16, Telum 2 is the IBM Z17, right? So again, very low latency, very high throughput for these predictive AI models. So this is, again, high volume, real-time transaction processing. This is where a lot of the use cases are going to be for the next number of years for IBM Z type of applications. Then we have the ideas of multi-model. So we want to have additional insights, not just predictive. We want to be able to add maybe some analysis of unstructured data, or to use a more complicated model, such as an encoder LLM model, right? A lot of those models can still run on the Telum 2 processor, okay? So the Telum 2 can handle encoder LLMs, but if it's a very complex encoder LLM, we might then say to run on the Spire accelerator as well. So again, be able to achieve higher predictive accuracy and expanded insights by leveraging some unstructured data that LLMs can provide. And again, being able to combine those two technologies. We're going to give you some examples to really drive that point home of what we refer to as multiple model AI. And then on the right side, we have something called generative AI. Generative AI, larger large language models that require a lot more computing power. And be able to run some of the Gen AI and assistant type of applications that are there that will require a Spire card. And of course, instead of encoders, decoder LLMs can run on the generative AI and the Spire adapters. Okay, so now let's just talk about, I'm going to skip over this slide for the sake of time. Let's talk about the multiple AI model technique and how that can be used. Here's a really good business scenario that we've heard some of our clients want to leverage this. They already have a machine learning or deep learning model that is evaluating their potentially fraudulent use case, right? They're getting a score back from that machine learning or deep learning model, and that score, let's say that they say, well, if the model says that if the model returns a score of 80% or higher, that suspicion that it's fraud, we're gonna block the transaction. We have a high level of confidence in that. Likewise, if it says that it's an 80% chance that it's not fraud, we are going to know that decision and do the normal process the request path. But what happens if we don't have a high level of confidence? What happens if the request, for example, was 75% sure that it's fraud? And we say, according to our analysis, we say we should only mark it as fraud if it's 80% or higher. So we have a request where it's like right on the borderline, whether it's fraud or it's not fraud, right? So what do we do in that case? Well, let's say 90% of our requests likely are getting that high confidence score. And so we don't need to do any further processing. But for these 10% of the transactions that maybe we don't have as high level of confidence, we can actually invoke an encoder LLM, which is maybe a more sophisticated model. It might take a little bit more time to execute, but because it is an encoder LLM that's not really, really complex, we can still run on the Telum processor, and we can still get that score in a very rapid time and still meet our SLAs, right? So we have a number of products that are going to be able to do that type of technology, right? And so some of those things include the AI Toolkit and Triton Inference Server and the Deep Learning Compiler. We can all leverage that technology right on the Telum 2 processor. So there's a number of other use cases, and for the sake of time, I know I only have about 6 minutes left. I'm going to focus on this last use case. I'm giving all these slides are available for you to go take a look. I'm going to give you an example of an insurance case. Of course, there's anti-money laundering use case here, but I'm going to go to an advanced insurance claims processing, a very simple case for us to understand of why we might be able to combine another use case where we do multiple models. So we want to use a machine learning or deep learning model, but we have some other data that is unstructured that we want to use as inputs into our machine learning and deep learning model. And what do I mean by that? We want to know what it was the cause of the claim, and we want to know what the urgency of the claim is if that information is known. That will help us make a more accurate decision about paying this claim adjudication, right? And so in this example, there is a claims narrative that someone can write, and they wrote this claims narrative here. 2 days ago, there was malicious damage. Here's my initial summary of the items, et cetera, et cetera, et cetera. Using an encoder LLM, and depending on how complex that encoder LLM is, it could run either on the Telum processor directly, or if you want to use a very complex one, it might need to use the Expire accelerator. I get from that analysis of that unstructured data, I'm able to determine a couple of factors. One is that the cause of the claim was vandalism, and two, that the urgency is really not urgent, right? And so I'm able to extract that data. Using those two pieces, I'm able to feed that into structured data. And now I'm able to say cause of claim, vandalism. It's part of the structured data, and the urgency, it's not urgent. Now I use a traditional model with that additional insights that I got from that unstructured data, and I'm able to have a much more accurate decision than I might have had had I not had those values in there. Okay, so that's just a couple uses of using what we refer to as multiple model. Now let's talk a little bit about generative AI. That's on the IBM Spire, the IBM Z17 Spire accelerator cards. Again, this accelerator card, it uses a fraction of the energy of an NVIDIA GPU. And it will satisfy many of the use cases for generative AI that are relevant to the IBM Z type of workloads that are on there. It uses only, again, 75 watts instead of maybe up to 10 times that amount for an NVIDIA GPU, right? It has a lot of memory, it has a lot of room, and again, large language models and generative AI are its focus. So what are the first things that you can run off of that? There's a couple of products that IBM has called, one is called the Watson X Assistant for Z, which is basically a conversational assistant that can now run on Z itself. So that means I can have my institutional knowledge in addition to the broad knowledge that's already available for IBM Z out there. And I can have my model have all of that running on Z, and plus the ability to have automation. So when you ask a question, it might be able to determine that you have an automation for that and suggest that not automation and actually invoke that automation for you after presenting you a form for you to fill out some details. Very powerful. We've seen a lot of uptake in this from our clients. And what the news here is that I can now run this Watson X Assistant for Z on Z itself. So this is really powerful. And then the Watson X Code Assistant for Z allows you to have a better visualization of what your code is running, maybe your COBOL code. I can analyze that code. I can refactor that code. I can optimize that code. I can explain that code, and I can optionally convert that code into things like Java. And there's other use cases just besides COBOL, PL1, and for example, JCL are some other examples. The key is I can run this Watson X Code Assistant on-prem on my Z platform. A lot of clients have said, I'm not shipping my code off to the cloud. That's my biggest asset that I have for my company. I need to run that on-prem. And so now you're going to be able to run both of these assistants with Spire cards on the IBM Z17. And of course, generative AI lends itself to lots of other use cases, right? So think about some of these use cases. Tax document processing, for example, financial document processing, be able to take documents that you already have and to be able to extract insights, to be able to summarize those things. Lots of use cases that are going to be able to use in addition to those assistants that we have there. This is just for your reference. You can look at it. What types of models what types of models can be run on the actual Telum 2 processor versus which types of models might require additional horsepower of the Spire accelerator. We also integrate with the Watson X platform in general, and this slide talks a little bit about that. We do have the last slide I'll just mention here is we do have something called the IBM on AI on Z Discovery Workshop, in which IBM will, at no charge, come to you and basically help you understand how to leverage the technology, what use cases make the most sense, and help you on your journey to have a POC leveraging this technology. So I've done a lot of talking right now, and right now these other slides are just for your reference. What questions do you have? Are there any questions that are out there in the chat? Or do we want to be able to unmute for just a moment for folks
Yeah.
to be able to ask questions?
Yeah, I'll unmute. Unmute.
Any questions about AI on IBM Z?
So please unmute yourselves if you have any questions. There's none in the chat so far. So we'll give them a minute.
Wow, either I bored you to death or I was such an awesome speaker that I answered every question, huh? That's pretty amazing.
I think it's the latter. Yeah, I think it was just such an amazing session. No,
Oh yeah. Well, it's great. So you know what I did? I put my email address on the front of this slide deck. So as you if you have any, I'm just going to just share my screen again here. So swarren@us.ibm.com. If you have any questions about AI and IBM Z, what our directions are for either, if you have an IBM Z16, you want to start now and have a workshop with us, come talk to me about it. If you want to understand, hey, I'm thinking of buying an IBM Z17 or the latest turn of the crank for Linux 1, feel free to come and reach out.
well, thank you so much, Steve, for that. As Aileen says, a tsunami of information. It was brilliant. Thank you ever so much for coming on and speaking to us all. And I hope everyone else enjoyed it and got their worth from it. So thank you ever so much, everyone. And I hope you guys are attending the last session of the day, which is the closing session. And hopefully I'll see you all there. Thank you so much, Steve.
You're most welcome.